Hello, Professor. For today, we're going to be talking about a survey on the security, interoperability, and the future of Amazon's Alexa. Here's my name, Juan Gutierrez, and my Panther ID. So really quick, we're going to be going over the abstract and introduction. Alexa is a complex speaker recognition-based artificial intelligence digital assistant with cloud-based voice service installed in each device. Alexa can turn on your car, communicate with your alarm system, turn your lights on, etc. So in this paper, we focused on the security and future interoperability options by going thoroughly through the privacy, current, and future use cases, user interactions, and opportunities for growth in the future. So really quick, we're going to be going over this graph. So in the first step, this is all to be able to communicate. This is what happens in the background when you communicate to Alexa and Alexa communicates to you. So what's happening in the background? I actually provided this reference link in my paper, so I did not copy this off the internet and I'm just using it now. So one, it streams to the Alexa cloud where it must go through an automatic speech recognition software and returns speech into the text, then stores that text in Alexa's data storage. So this is so if the command gets lost, it can still be retrieved. Then the ASR then sends the data to a natural language understanding software where it must interpret text as list of possible intents, commands, whatever. Then step 4 is if there is a third-party device, right, over here, let's say that's your Nest, your thermostat, whatever, your car, it would then send this info to the third-party device for processing. If not, so here it's going to have an if statement. If not, it continues here through this path. If not, it will determine if it can handle the command it is asked to do. If it can handle it, then it will use the text-to-speech software to translate skill output to speech. Then it sends it back to the user as a voice response. And yeah, that's it. Now for the next one, we're going to be going over important user data to consider. So the first part is 68% of participants reported using Alexa to control external devices. So interoperability is being used here. There is a use case for it. This means that Alexa is being used for communication between external devices. So third-party device communication also has an 89 to 12% satisfaction to dissatisfaction average rate according to the Alexa users. This means that satisfaction is 89%, if that wasn't understood. Now, it can be assumed from this data that interoperability within Alexa has been a great success and is very important to the company, but users still have some concerns with hearing issues and slow response times. These issues can be relatively minor if it isn't the most used technology, but if interoperability is lacking behind simple tasks such as asking them for the temperature and stuff like that, what is the usage rate between features? So here in this figure, we're going to be going over that it is actually the least frequent used Alexa interaction, the control external devices. This implies that most important use issues to deal with is not the future development of interoperability. It's the minor bugs that are making the users work harder than they need to. Why? Because of the fact that they develop a trust between Alexa, the technology, with the simple tasks, asking the weather, asking the news, playing the music. That's how you develop trust between the actual development of you and the technology. You won't want to control external devices on a device that you don't trust. Why would you want to connect your cameras to an Alexa that you don't trust? So you have to improve all of these other things, make sure all of these other things, the weather, the facts, news, simple things, are bulletproof per se. So what are some already existing security measures behind all these things? Amazon already provides basic methods of privacy for a user. For example, if there is a moment where you would not like your Amazon Echo device to respond to the wake word Alexa, you may toggle the on and off button. If the button is red, it signifies that it's off. It completely disconnects all electrical current going to the microphone. When designing the Alexa, they made it so the electrical current can only go to either the microphone or the red LED, but never both at the same time, meaning it can be turned back on by the software. But it can't be turned back on by the software, only by the physical touch of the user. So the user actually has to manually do it, or else it will never turn off. Now, Alexa gives you the option to secure yourself when you're not home. With Alexa's new Guard Plus software, you can allow Alexa to take care of your home when you're not there. If Alexa notices that an intruder is at your house, it will go into a state of panic by turning on and off your smart lights and play the sound of a dog barking. Now, in the paper, we actually go a little bit more in depth about to this. I feel like it actually is kind of a shadow behind the doubt of the fact that these people are going through a bunch of different tasks before they see all of this in the background. They won't even see any of this in the background if they see many issues piling up in the beginning. So we go into more detail about that in the conclusion. We'll read that in, but yeah. So another thing is the current issues reported by customers: mishearing, slow response time, connection drops, stops recording your voice at random times. This gives the appeal that it's not a trustworthy object, even though it is, but it makes that appeal that it isn't in the beginning. So AWS integration with Alexa. So what's happening in the background? What's really happening? So one of the biggest tools that Amazon has for Alexa in terms of interoperability is Alexa Voice Service. Now we're strictly talking about IoT here. It enables any device that is connected to the Alexa to become an AWS built-in device. This offloads compute and memory-intensive tasks from physical devices to the cloud. Until now, smart home devices were built with microcontrollers that have a limited memory in order to run properly, but now you can easily offload memory to your virtual Alexa built-in device information into the cloud. Now, the next thing is, I know that the picture is a little bit blurry. This is the best that I could do, but I'll explain to you what's happening here. So first, the smart devices using microcontrollers like ARM Cortex based devices with less than 1 megabyte of embedded RAM send info to the AWS IoT Core, which is the major service name for the microservice AVS. Then AWS IoT Core then securely and easily connects your device to the cloud and to other devices with AWS IoT Core. Then AWS IoT Core receives audio messages from the device and delivers them to AVS through secure MQTT topics. Then the virtual Alexa built-in device processes the audio data and sends the response back to the device through AWS IoT Core as a MQTT message, and that's about it. So it goes through here, goes back. How does the speech recognition software work? So this provides the biggest issues in the forefront. This is why people complain a lot. It takes the audio heard by the user through the microphone and makes it into strings that are sent into the natural language understanding system. We talked about that in the beginning of the paper in the introduction. So possible scripts. This is just examples. They're just asking what is the weather in Menlo Park, right? So what the system does in this case is grab the string and score each possible string and pick whichever has the best score to get used. If the customer is trying to reach their third-party device through one of these devices, it will not share personal information unless specifically asked to. The only thing is that this has been proven to not work. I mean, if you have an Alexa, you'll see that this is not always efficient. In the paper, we go a little bit more into depth as to what Amazon is doing right now to be able to fix it. but it's still in testing. That's why I briefly only explained it in the paper. I didn't explain it in here because we only have 10 minutes. Now, in the conclusion, in this work, we explored what Alexa is, how the background communication between user and Echo works, privacy, use cases, user interactions, improvements coming in the future, opportunities for growth, and Alexa's voice integration. There are three main arguments in this survey. So the first argument that I go to, it's actually two. I'm going to go fix that right now. First argument is data points to the fact that the user interoperability in Alexa is revolutionizing the world of IoT as we know it, with Alexa Cloud increasing the total throughput capacity of any device connecting to it while being digital secure on a digital cloud. There is clear use for Alexa's interoperability features and improvements on the existing platform, since 68%, as I mentioned before, and on the paper, of Alexa users may ask it to communicate with other third-party devices, which is why there is so much development behind it. So it's clear that the dream right now behind Alexa is to become an internal processing hub, smart hub, let's say, for all things smart in your home. Yet data differs with Amazon's beliefs, as the common person seems to use Alexa primarily for music and weather, which is where primarily most of the issues come out. Now, due to this not being the original focus, yes, purpose it is showing many minor issues such as mishearing and communication loss, connection loss, which brings us to our second argument. Now, our second argument brings into contact with, it comes to actual security of technology. Having the customer's trust is key. We talked about this before. So if a customer sees issues in the minor things, like mishearings, they won't care what is provided as far as security externally. So Amazon does many things to hide these issues, like Amazon Guard Plus. I don't feel like I've never seen that marketed. But it's all for naught. If the service can't even listen to the customers properly, then people won't want Amazon Guard Plus. Luckily, there are some solutions Amazon is looking for to provide for this, such as acoustic and hypothesis embeddings. That's a little bit too complicated to talk about in here for the time limit that we have. I put a lot of detailed information in that in the paper, and I also put the references and the numbers for the references. But that's it. Thank you, Professor.